as we pick up in Lesson 8.3 today, hyperbolas, you will notice a lot of similarities. A lot of similar vocabulary, a lot of similar formulas, but you'll also notice some definite differences. So, yes, Jacob? I think I know who it is then. Because I noticed it after, it's an Algebra 2 note packet, isn't it? I noticed it yesterday afternoon, so it's probably my 6-hour person. Okay, and so hyperbola, if you look at this definition, should sound somewhat familiar. It's a set of all points in a plane whose distances from two fixed points have a constant difference. If you go back and compare that to the ellipse definition, the only word that was different is it was a constant sum. So when you took those two distances and added them, it was always the same. With hyperbola, the set of all the points whose distances from those two fixed points have a constant difference. So when you subtract those amounts, it would always be the same. Those fixed points that we're talking about are the foci. So just like an ellipse, you have two foci. Now notice as you start examining this picture, okay, so here's my hyperbola. My hyperbola, basically, if you think of an ellipse as two curves facing in towards each other, the hyperbola takes those two curves and flips them out. And so we have two curves facing out from each other. You will notice that the foci are right there. They're what I would say inside the curve, because like if you think of the curve as being like cupped or whatever, it's inside that. So your foci are inside the curve there. The line through the foci is still called the focal axis. So that is going to be, that doesn't look like it's drawn right actually. I don't know that I sometimes remember to catch that and sometimes don't. Officially, focal axis is going to go from foci to foci, or focus to focus, so it really should be more along that line. Sorry about that. And so focal axis connects your two foci. The point halfway through the focal axis is called the center. So just like an ellipse, you have a center marking the center of the object. The points where the hyperbola intersects its focal axis are the vertices. So you have two vertices right here. In the ellipse, the vertices were the ends of the ellipse. Well, it's still kind of the same points, but it's the center of the actual hyperbola curve. So two vertices. The chord, so the line on the focal axis connecting the vertices, is called the transverse axis. So instead of using, this is one of the differences, instead of using major and minor axis, we use transverse axis and conjugate axis. The transverse axis being the axis that goes through the vertices and foci. And then the perpendicular line through the transverse axis is called the conjugate axis. So there's not anything drawn for it right here, but it would be the vertical line going through the center. That would be your conjugate axis. So similarities, but also a few differences. We're going to start, kind of like we did with the ellipses on this first page. We're just looking at hyperbola centered at 0, 0. As you look at these, notice again there's a left column and a right column. What's different about my equations this time? They probably look pretty familiar. There's one small difference between an ellipse equation and a hyperbola equation. We're subtracting instead of adding. And if you think about back to that definition, it makes sense. So hyperbola equations look very much like the ellipse, but notice it's subtracted. You still have a left column where x squared over a squared except minus y squared over b squared equals 1. And then in the second column, your x and y flip-flop. In the second column, in that right column, it is more obvious this time because that y has to be positive. Whereas over here in the first column, the x has to be positive. As you compare the pictures, in a left column hyperbola, what I say is your hyperbolas are on a horizontal axis because they're opening apart from each other horizontally. And so kind of like how the ellipse has the longer axis that way, for the left column here, my hyperbolas are opening up on a horizontal axis. As opposed to my right column, where my hyperbolas are opening up vertically. You have one opening up, one opening down. So they're on a vertical axis. You've got similar information. If you go back and compare this to ellipse, a lot of it's the same. On the left, the focal axis is the x-axis, so that's your kind of your major axis in a way. On the right, it's your y-axis, so it's vertical. Foci and vertices, you'll notice are still the same. Foci are still your C values. Vertices are still your A values. Instead of major axis being 2A and minor axis being 2B, we now have transverse axis being 2A and conjugate axis being 2B. What do you notice about the Pythagorean relationship? Yeah, the sign switched again, didn't it? Pythagorean relationship we've been using with ellipses was a squared minus b squared. Pythagorean relationship with hyperbolas is a squared plus b squared. One way to make that connection is the Pythagorean relationship has the opposite sign of what standard form has. Standard form here, we're subtracting. My Pythagorean relationship is adding. And then something new we're adding in, asymptotes. Okay. If you think about asymptotes, we've talked about asymptotes a little bit, but asymptotes are traditionally lines that are drawn as dotted lines, and they are lines that your graph might run alongside, but never cross, never touch. Well, with the hyperbolas, and this will be something we'll practice, in order to draw a hyperbola effectively, we have two diagonal asymptotes. And what it is those, depending on the angle of those asymptotes, that will help indicate how wide my parabola opens up or maybe how skinny my parabola opens up. It'll just kind of depend. So we will definitely practice with asymptotes and drawing them. You're not actually asked to find the asymptotes or work with them too much. Maybe just a little bit at the end of the lesson. But when I talk about how to draw this, I'll actually show you a different way to draw your asymptotes rather than using the equation. We'll use our A and B values, but I'll show you a little bit different way. Okay. Looks like some of you guys have started looking at example 1. Example 1. Find the vertices and the foci of the hyperbola 4x squared minus 9y squared equals 36. Well, what do you know? Before I can find the vertices and foci, I should probably put this into standard form. And what step are you taking to put this into standard form? Dividing by 36. We want to make this right equal to 1, so we're going to divide by 36. We're dividing the right by 36. We're dividing all the pieces by 36. Okay, 4x squared over 36 becomes x squared over 9 minus 9y squared over 36 becomes y squared over 4 equals 1. Okay. First of all, if you want to write it to match one of the equations, you could write this also, instead of saying x squared over 9, we could say x squared over 3 squared and y squared over 2 squared. So do remember those denominators are a squared and b squared. Is this a left column hyperbola or a right column hyperbola? Left. And why is it left?
Because the a denominator is greater than b.
Not necessarily. Okay, so let me, this is one of the differences that we have to watch out for. A is not necessarily always bigger than B in a hyperbola. Okay, leads to a little bit of confusion at times. A does not have to be bigger than B. That's not what leads me to say that this is left column. There's something else that is, yeah, which is our positive variable here. And x squared is our positive variable. And so that right there is what tells me, because this is an x squared as my positive variable, that is what tells me this is a left column problem, is because the x squared comes first as the positive variable. A can be smaller than B, so beware. We will run into that at some point and it will get you. So, trying to give you advice ahead of time though. While we're here, while looking at the equation, what are A and B? A is 3 and B is 2. So what you need to kind of remember is that in this one, A squared is always under the first variable. So it's always under the positive variable. Okay? B squared is always under the second variable. And this is assuming that you put the positive variable first. Okay, what did we need to find? Vertices and foci. So, since this is left column, what do we know about vertices? How does it say I find the vertices? They go back to left column. Vertices are plus or minus a comma 0. And we know that a is 3. So like previously, I'm just going to say plus or minus 3 comma 0. Foci? Well, if vertices are plus or minus a0, then foci are plus or minus c comma 0. And what's the catch here? I don't technically know c. How do we find c? Yeah, it's a Pythagorean relationship, but realize this time it's c squared equals a squared plus b squared. So do the math. Let's see. I'm going to say 9 plus 4. So c squared is 13. So c is the square root of 13, if you will. And so that means my foci that are supposed to be plus or minus c comma 0 plus or minus square root of 13 comma 0. Questions on that one? Excuse me. Okay, shall we try example 2? Now, I don't know how much you guys remember about the ellipse examples we did a couple of days, but these are lining right up with those. So, find an equation of the hyperbola with foci 0, negative 3, and 0, 3, whose conjugate axis has length 4, and then sketch the hyperbola and its asymptotes. So notice we are trying to find an equation, and we are sketching. Okay. What are the pieces you're noticing? C is 3. So right here we have foci, yes? And my foci are C. Officially, since this is 0, -3, and 0, 3, this means my foci is 0, comma, plus or minus C. Because if you look back at our chart, my foci for something centered at 0, 0 are either plus or minus C, comma 0, or 0 plus or minus C. I already forgot by changing pages. In this case, since I'm 0 plus or minus C, what does that tell me? We're going to be in which column? This is a right column problem. We know that because of our foci, right? Because that 0 comes first, that's what tells me that this is a right column problem. If I go ahead and write out my right column formula, realize I'm going to be filling in eventually y squared over a squared minus x squared over b squared equals 1. And that's because it's a right column problem. What other information is provided here? Conjugate axis has length 4. What do we know? Conjugate axis is my minor axis. So 2b equals 4, and thus b equals 2. And what do I need before I can write my equation? I've got B and C, but I really need to find A. How are we going to find A? Yeah, Pythagorean relationship. Check that Pythagorean relationship and remember that it is C squared equals A squared plus B squared today. So 3 squared equals A squared plus 2 squared. So 9 equals A squared plus 4. A squared is 9 minus 4, so that's 5. And A is the square root of 5. In order to write our equation, A is the square root of 5. That's enough to know. It would be helpful to know what the square root of 5 is when we go to graph this. Okay, because we're going to need to be able to count out A, however far A is. And so, what is the square root of 5 approximately? It's 2 point something. I have 2.23 written down in my notes. I mean, just knowing that something around 2.2 is helpful there. Okay, did you write your equation? Okay, y squared over a squared. If a is the square root of 5, then a squared is 5 minus x squared over b squared, 2 squared, which is 4, equals 1. First equation written. Okay. We ready to learn how to graph these guys? I will say there are some similarities to graphing the ellipses, but hyperbolas are definitely one in their own here. So I'm going to set up my axes here, smack dab in the middle. Probably made that x-axis way too long, but that's all right. Let's see. I think the farthest we ever count out is 3. So I just put 3 tick marks on going out each direction of my axes. Yeah, we didn't need to go 3 both directions, but that's all right. Okay, so my center point, this is a hyperbola centered at 0, 0, yes? Now, it's not that there's even really a point there. That's just kind of where everything is centered around. We can go ahead and graph foci, yes. We were given our foci of 0, negative 3 and 0, 3. And so if I count 0, negative 3 and 0, 3, those are those points right there. Okay, that was counting up 3 and down 3. And those were foci, right? Sometimes label them with F for foci. Keep in mind, your foci are also your C value, right? So even if it doesn't tell you what your foci are, as long as you know your C value tells you how far to count out for your foci. So you count out C from the center. So since C was 3, we count out up 3 and down 3. And keep in mind, we go up 3 and down 3 for the foci in this one because we decided this was a right column. And if you go back and look at the picture, what's happening with a right column? With a right column, my hyperbolas are going to open up and down. Okay, now, so those foci are points inside the curves. My A and B values are what are going to use to help us. I'm actually going to use my A and B values to draw a box or a rectangle. And we're going to use that rectangle to draw our asymptotes. Also keep in mind your A value is going to be your vertices. Just like your foci are C from the middle, your vertices are A from the middle. What is my A value? My A value was this square root of 5. This is when I'd really like a whole number, but we weren't given that. So we're going to deal with square root of 5. So if A is square root of 5, it's going to go on the same axis the foci are, and that's going to take us to our vertices. So I'm going to go up 2.23, and I'm going to go down 2.23. If I go back and show you on this picture here, right here, there's A, there's negative A. Just like here's C, and here's negative C. Okay? So right here, these are going to be my vertices. It was that 2.23, and it's also important to know that those are my A values. Now, my A values and C values are on the transverse axis, aka the major axis. My B values, well, keep in mind, last time my B values were on the minor axis, right? So my B values are going to be on the conjugate axis. And what I'm going to do with my B values is I'm going to count out 2 from the center on the other axis. Now, I'm putting dots here just to kind of mark those spots. Technically, I don't know, technically they're not dots because they're not part of the graph. But for me right now, what I'm doing, I kind of mark where I'm going to mark everything. Okay? We're going to use our A values and our B values to form a rectangle. So I'm going to draw dotted lines through the level of the vertices and dotted lines through where B is. Okay. So I use my A values and my B values to create a box. My B's are kind of getting... Are we okay with the box? Because my asymptotes, if you go back and look at asymptotes, it said my asymptotes are going to be plus or minus A over BX. So that's saying they're going to have a slope of A over B. Well, here's what I do. I draw my asymptotes through the corners of the boxes. So we have a positive asymptote and we have a negative asymptote. And let's see, I'm going to try this light gray and see how I like that. So I'm going to have one. It needs to go through the corner of the box, needs to go through the center, which my center in this case was 0, 0. That's one asymptote. Goes through diagonal corners of the box, goes through the center, 0, 0. I'm also going to have another one. I can't draw this. Goes through the center, goes through the corner of the box, and that's my other asymptote. Yes, these will be a necessary part of drawing the graph because my next job is to draw my hyperbola. And this kind of gives me an idea of how wide my hyperbolas are going to go. I'm assuming you guys can see that light gray. Okay. Now, my hyperbolas, what makes that point of the height, it's not a point, but where do I find that? How do I know where to put the parabola or hyperbola? And we're going to use our vertices. So right here, I had a vertex, and right here, I had a vertex. They were my A values, right? So we're going to use that to draw our hyperbola. Our hyperbola is going to go out, and it's going to run alongside, or curve kind of alongside, your asymptotes. And look something like that. Okay. Remember, my foci are points inside the hyperbola. So if you're giving your foci, those foci should be present there. And you've created your first hyperbola. I do think graphing the hyperbolas is a little more difficult than graphing the ellipses. However, what does make it, at least you guys are already kind of familiar with the whole idea of the A's and the B's and counting out from the center. Questions there? Before we work on the next side a little bit? Yes, Jacob?
So, like, our hyperbola is kind of like if you took a parabola and you took the asymptotes and you just, instead of straight up and down.
Technically, a parabola and a hyperbola are different shapes. Because a parabola is going to go, it's going to be more likely to be narrower, where hyperbola is going to go out wider. I mentioned the other day, if you remember the reciprocal function, which the reciprocal function was the one that was like that. That's a hyperbola right there, except instead of it being a vertical or a horizontal one, it's a diagonal one.
That's what I was thinking.
Yeah, that right there, the reciprocal function, that is a hyperbola, just twisted at a diagonal.
Yeah, I got those mixed up.
Yeah, okay. Yes?
Okay, so, like, on the test, if A and B are both whole numbers, could we just graph the asymptotes without doing the box? Like, do the A over B.
In other words, you're just saying you graph the line? Possibly. Where it gets trickier is when they're no longer centered at 0, 0. And that's where I encourage the box because it just kind of simplifies it. I'm not going to say you couldn't just graph the, asymptote, and as long as it's accurate, I'll take it. I will say what I usually look for is the box to be drawn, and then if it's correctly done, your asymptotes go through the corners and the center. On something like this, I could see you getting away with not doing a box and it being good. When the center's not 0, 0, I question how well that would work. Does that make sense?
Yeah.
So. Okay. I'm going to take that off. Ready for the next one? Okay. Top of the next page. Guess what? You had 2 charts on ellipses. Guess what? 2 charts on hyperbolas. Again, remember, you'll have a whole big, instead of a page of notes you get to use, it's more like a packet of notes you get to use, because by the time I provide the parabola information, the ellipse information, the hyperbola information, there's a lot there. I mean, hyperbola information will be a page itself. The ellipse information will be a page itself by the time I put both charts and everything there. So, okay, hyperbolas. These are centered at HK. I'm guessing the equations are probably what you would expect. Basically, instead of x squared and y squared, it's x minus h squared, y minus k squared. Left column is still x is the positive exponent, positive variable. Right column is still y is the positive. Focal axis. Well, instead of it being the x-axis or y-axis, it's y equals k or x equals h. Foci and vertices should look familiar, right? It's hk, and then it's the plus or minus c or a, whether it be on h or k, depending on the column. Transverse axis, conjugate axis, 2a, 2b. Pythagorean relationship, still there. And now notice what happens with our asymptote equation. Okay, this is where it's a little uglier here, isn't it? And that's where, I don't know, you might be able to draw your asymptotes okay, because you're still using the same slope, but going from a different center. It makes it a little bit more difficult. But there we have formulas for asymptotes. Eccentricity is back. Eccentricity is still E equals C over A. No change there. If you continue this part, how you find C is different. It's square root of A squared plus B squared instead of the minus. I don't know if you remember what the ellipse said, but with an ellipse, eccentricity was always a number between 0 and 1. And it was how elongated is your ellipse. With a hyperbola, eccentricity is always bigger than 1. Always, always, always bigger than 1. And it talks about how wide the hyperbola is. Okay, so talking about how wide that curve is. Okay. I don't know, can we get example 3 done? Might be able to. We're going to try it. If I leave off in an awkward spot, what's new, right? So, example 3. Let's see what we can do with this. Find the standard form of the equation for the hyperbola whose transverse axis has endpoints -2, -1, and 8, -1, and whose conjugate axis has length 8. So officially, have to write an equation. I'm going to talk about the picture a little bit on this one as well, because I think that will be helpful. And it's good practice. I want to make sure that we're drawing some of these. But what do you have to point out to me on this one?
It's a left column.
He says it's a left column. Why would you say it's a left column?
Because for the transverse axis, wait. Yeah, for the transverse axis and stuff, it has A is X.
A isn't exactly X, but A is part of the X variable there.
Yeah.
Okay, so I agree with him. He's trying to figure out how to tell it to me, but I do agree with him that this is a left column problem, and these transverse axis endpoints are what can tell me it's a left column.
Is it the same K value?
Yeah, okay, because, and that's what I would look at right there, is that both transverse axis endpoints have the same Y value, which is going to end up being your K value.
Somebody's series.
Ah, okay, we've triggered. I was like, I heard something. You guys are all looking at each other crazy like. So, okay, so Siri's the one that's throwing us off back there. Okay. So yes, I agree. This is K. What's the official vocabulary word for transverse axis endpoints? What are those? What's at the end of the transverse axis? Vertices, yes. If you remember, the ends of the major axis was your vertices. Now it's the ends of the transverse axis. So these endpoints right here, when it talks about the ends of the transverse axis, these are vertices. And so that altogether tells me that this is a left column problem. Whoops. That I don't know how to spell. There we go. And if you look on the paper is going to say that this is H plus or minus A, comma K. So thus, we know our K value. Now, while I'm here, I'm going to write, since we're in a left column, I'm going to write out that I'm going to be doing X minus H squared over A squared minus Y minus K squared over B squared equals 1. Okay. What other information you got for me? What? You're gonna be quiet?
Conjugate axis is
Yeah. Okay. Conjugate axis is 8. And so if we use the idea that the conjugate axis is 8, what is the conjugate axis represented as? That is 2b. So if 2b equals 8, then b is 4. How long is the transverse axis? How long is the transverse axis? Can you do this without a picture? Some of you can. Maybe all of you can. If my transverse axis goes from -2, so left 2, down 1, and it goes right 8, down 1, what is the distance from -2, -1, to 8, -1? In other words, what's the distance from -2 to 8? And that's 10, yes? So if you can visualize that difference, we can say, okay, the transverse axis, 2a equals 10, so a equals 5. The other piece of information I need is the center, which, keep in mind, the center is HK. Some of you can do the center without a picture. Maybe all of you. I don't know. Maybe I'm, Where is the center going to be? It's going to be the middle of the transverse axis. So what's the middle point of -2, -1, and 8, -1? So what's the middle of -2 and 8? You're counting in 5 either way, right? Either subtracting 3 or adding 3. And so we're going to have a 3 and a -1. And I just looked at the clock. Dang it. You have the information to write the equation here, don't you? I would like to graph this. We get over at 10:14, right? Okay. So tomorrow, I need to write the equation for this one. And I want to graph it because some of you right now are perfectly fine with what I've done. Some of you may be lost on A and H and K. And so I want to show you a picture and put that all together. So we'll end in this awkward spot. You are welcome to go ahead and start homework. I mean, the ones, if it's like yesterday's, the beginning of the homework will be more the ones focused at 0, 0. But homework will not be due until Monday, I guess. So if you want less homework over the weekend, definitely get started, right?